Here is the answer for day 2. Graph this function. This is the cosecant function, which is the reciprocal of the sine function. The technique that we use to graph these by hand is to lightly sketch the graph of y equals sine of x over 2. And then use that graph to actually draw in the cosecant graph. So in blue ink, I'm going to graph this, and then I'll change colors and actually graph the cosecant function. So this function right here has a value of 1 and a b value of 1/2. There's no c or d that are important here. We know that the a is involved in identifying our amplitude, our maximum at 1 and our minimum at -1. And the letter b is involved in finding the period. So let's find the period. The formula is 2 pi divided by b. So 2 pi divided by 1/2, and that makes 4 pi. Now the grid that's laid out here on the paper doesn't actually go out to 4 pi. So what I'm going to do is I'm going to cross out these values and make them be something that better fits this problem. 1, 2, 3, 4. Let's make that fourth mark be 4 pi. Then the 1 halfway in between is 2 pi. This one here is pi, and this is 3 pi. Similarly, going to the left, those would be negative versions of those numbers. Now let's graph our function. When x is 0, the sine of 0 is 0. So there's a dot at the origin. After one full period, there'll be another dot at that same height. Now what's happening halfway in between? When x is 2 pi. If you replace x with 2 pi, then 2 pi divided by 2 makes pi. And so you'd be finding the sine of pi. The sine of pi is 0. What happens halfway between here and here when x is pi? If you replace x with pi, then you'd be evaluating the sine of pi over 2. The sine of pi over 2 is 1. So the dot is at a height of 1. Halfway between this dot and this dot, when you're at 3 pi, is when you'd have a sine value, that is -1. So here in blue ink is this section of the graph of y equals sine of x over 2. We could continue that to the left as well. There'll be a dot here, 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 and here. Now we are not done yet. We just graphed y equals sine of x over 2. But this question is really about doing y equals the cosecant of x over 2. Cosecant is the reciprocal of sine. So what we're going to do to get this answer is to identify some vertical asymptotes. They will occur at all of the x-intercepts of our sine graph. And so we're going to draw dashed lines through those x-intercepts. If the sine is equal to 0 at these points, and cosecant is the reciprocal of sine, you can't find the reciprocal of 0. That's why we're drawing these asymptotes. Now we're ready to graph the cosecant function. Start close to the asymptote, and as you come down here, curve and go through that maximum dot, and then curve it back up and alongside that asymptote. In this area, it starts along the asymptote, goes through that minimum dot, and then curves and goes along the asymptote over here. In this section, start up here along the asymptote, go through that dot right there, and then curve it on up along the other asymptote. And finally, this last section. So we used the sine graph to draw in our cosecant graph. At this point, you could erase your sine curve because the sine curve is not what you were asked to graph. It's the red colored graph that is our cosecant function. Let's take a look at this on the calculator. There's not a cosecant button, but cosecant is the reciprocal of sine. So I've typed 1 divided by and then in parentheses, the sine of x over 2. Notice the double parenthesis here on the end. The first parenthesis just to enclose the x over 2, and the second parenthesis to enclose the fact that that entire thing was our denominator. Then press graph. You'll notice that it does make those U-shaped curves that we had in red ink. Now, are those curves located in the same place that we have on our paper? Let's press trace, and then second pi. I'm going to hit enter. Notice that it shows us the blinking cursor here at the bottom of this U shape. And when you look over on our graph on paper, that it is the bottom of the U shape that is located here at pi.